human being and I live in Cardiff in South Wales. So I graduated with my bachelor's degree back in 2017 actually, but I still see myself as being at the very beginning of my career. So since 2017, I've worked in entry-level development jobs before going back to uni to study a master's degree in applied software engineering at the National Software Academy in Cardiff Uni. So the knowledge I learned from my degrees is very valuable to me. They taught the foundations of information security, including networking, operating systems, penetration testing, and the human factors such as social engineering, and then compliance such as policy writing. And then there's a software engineering master's that I just completed, where I learned web development, Java fundamentals, agile methodologies, user experience, machine learning in Python, and DevOps. However, there's one area that both of these courses missed: application security. So having a background in InfoSec gave me the realization that I needed to ensure that my code was secure. A lot of people just write the code, they just want to get it done as soon as possible. But I've not seen firsthand, but I've done a lot of research during my undergrad to know just how bad it can be if code isn't secure. And I've done a small amount of pen testing, so I knew for myself how easy it was to get into insecure systems. So I researched myself how to write secure code because it wasn't part of any of the learning that I'd done in the past. So I'm still learning. I've only just started putting all the pieces together to allow me to learn to write secure code, but that's great because I, for one, prefer to learn from someone who's still learning themselves. So if during this talk I get anything wrong or there's any suggestions you guys want to give to me, please let me know, because I want to learn and feedback is always appreciated. So this talk today will be on API security. I didn't really know what an API was before this year. I'd done a small project in my dev job that I did alongside my master's. I started that job back in February, and I was supposed to be going full-time this September, but sadly the whole team got made redundant due to COVID. But during that, I learned so much, and the first project I did there was using APIs using Go. So I accessed an external API, and I learned how to use curl to send a request to the API. I then took my knowledge from that and looking at the responses and put that logic into an application, the one that was written in Go, where it sent the request to the API and it filtered the response for the select information that was then displayed to the user. It used several different APIs. It should have had the correct data. All the APIs, the responses should have all been the same. But obviously sometimes they're updated at different times. So it made sure that all the responses were the same. And if there are any anomalies, it actually didn't give it. But if they were all different, it actually printed them all out. So it was a really simple app, but it was perfect to teach me exactly how API responses worked. So, you know, I still didn't really know how to create an API at all at that point. I knew how to use one correctly, but I didn't know how to make one still. So that's when my dissertation project came in. So at the National Software Academy, assignments and final projects are based on group work. Teams of 3 to 5 people use agile methodologies on a project brief supplied by an industry client. So my team had the brief of creating a sentiment analysis tool to be used with the client's current system. So in order to do that, we'd make a back end. We chose to make it microservice because it didn't need to be anything fancy. And then we could hand it over to the client and they could connect it to their own front end and to their other back ends. You know, I like microservice architecture, so I really liked making that. But in order to test it, we also made a front end. So we made a Vue.js application, but that was just really to mimic the client. But this is when I really realized that if we're going to make this API and it's going to be used by an actual client, then it needs to be secure, definitely needs to be secure. So I went with what I know, and I turned to Twitter and I asked for help. You know, if anyone knew where I could start off with learning about API security. Because, you know, I had no idea where to start. Sorry. Can you all hear me okay, or am I breaking up?
I can hear you fine.
Okay, that's right. Sorry. Someone give me a prompt. So yeah, we were making the so yeah, with making the API, I turned to Twitter, and one of the first responses I had was someone suggesting I look into OWASP API top 10. So it was actually released in 2019. So it was a really good one to use for dissertation because it was so new. Not that the original OWASP isn't good at all, because it is. It doesn't really matter when it was made. It's still useful now. So I knew of the OWASP top 10, but I knew less than I should have, because when it comes to hacking, I'm a script kiddie at best. So the way OWASP is written is quite complicated. Well, to me, it's quite complicated because I'm new to the terminology. So the project was a 12-week full-time project, with the first 2 weeks being the planning and the last 2 weeks being the write-up for the dissertation. So only by the 9th week had I begun to understand all of how the OWASP API top 10 works. And then by then, a lot of the coding had been done. So it gave me a lot to say in the how would I do it better next time section of my dissertation. So my take of the subject still isn't perfect. I'm researching more into it so that I can make my own videos on it and teach it to others. But I think that's what's going to be good, is that I'm still learning, I'm still remembering the nitty-gritty things that I found difficult. And also, if you can teach something to someone else and other people understand it, then you know the subject really well. So it's a great way for anyone to learn, is to teach it to someone else. So what is an API? And I have some amazing diagrams here showing you what an API is. They're just very high quality. So it's short for Application Programming Interface. And the example I always turn to is Facebook and Instagram. So before Facebook bought Instagram, this was a lot easier to keep them separate. But it's also quite good because it outlines a microservice architecture in that they share databases. So anytime any code connects to a database, that's using a REST API. So that connection between the database management system and any application is through an API. And that's why you have a config file that has the password, and that's how you authenticate the connection to the database. So Instagram's front end would be a node, and then wherever the images are being saved, because they save the images to Facebook's databases, that would also be a node, and the connection would be between there. If you want to visualize it, when you post to Instagram and turn the share to Facebook option on, that's also an API. And I'm realizing out of all of us here, I'm probably the least versed on this topic. So I'm really sorry if this is really basic. But another really cool one is the one I'm using right now that I learned about today, is the Prezi and Zoom one. That API is really cool. how this is working right now. It's so cool. So in the two very high-tech diagrams you can see, there are very basic API frameworks. So I think I can click on it and it should get bigger. Yeah, okay. So here, node 2 is requesting data from node 1, and node 1 is an API endpoint. Node 1 then responds to node 2, and if node 2 has the correct authorization to access the data requested, then the response will contain that data. If not, the response will be an error code. So these responses are often JSON format, and there is a specification called JSON API spec that's commonly used, and it's a standard for API communications. So the second image shows 3 endpoints. So let me go on to that one. Very, very high tech. I realize that you can't see me now, but that's cool. So in this one, you've got the 3 endpoints on the one application. And the requester is first sending a request to the login endpoint. So what it means to code with security in mind is that the first endpoint you'd make, and correct me if I'm wrong, would be the login endpoint. Because then you would have the basics to add your security to every other endpoint. So the first endpoint a requester would request would be the login endpoint, where they would get their API key or their token, which they would then send to the next one they wanted to request. So it would be the IP address and then /ABC. And then you would, let's not get the syntax wrong, but I think then it would be $token equals, and then the token string. I might be wrong though. And then that would give them whatever access they wanted to gain, as long as they were using the correct HTTP request. So they'd be get, put, post, or delete. So endpoints could have all of them, or just one, or none of them. So then if you do gets to ABC, you'll get the information back in the request. So that's how a basic one works. Without the login endpoint and without the need for any security, you'd be able to request any of these endpoints just by knowing the endpoint name and the IP address. So the next thing I will talk about is finally the API top 10. And again, some very technical write-ups here. I just thought it was cute to do this. So here's the API top 10. So you've got broken object level authorization, broken authentication, excessive data exposure, lack of resources and rate limiting, broken function level authorization, mass assignment, security misconfiguration, injection attacks, improper asset management, and insufficient login and monitoring. So this took me a long while to research this, mainly because for someone who's been doing it a long time, it might be quite easy, but well, for me, it wasn't. So this next image shows an example for broken object level authorization. So if you have authorization to view IP address /person1/info, if you get given that to see your own information or another person's information that you have authorization to see, there's a chance that there might be broken object level authorization, which means that if you swap the 1 for 2, you can also see information for someone who you're not authorized to see. So this happens when you give people all access by default. So each thing between the slashes, so person1, that'll be an object, info, that'll be another object. So you can give people specific access. So if someone only the people who should be able to see the information for person 1, and this is very important with GDPR, should be able to access this one, the top one. And then only the people who should be able to see person 2 should be able to access the bottom one. But a lot of the time, if you can assume which one, if you can assume the name of another object, then you can often see information that you shouldn't be able to see. So the next one is broken authentication, or none at all. So this would be if you didn't have a login endpoint or any kind of tokens or keys. And the best way to do this is to use a well-documented, well-known technology such as JWT, which is JSON Web Tokens, or OAuth. If you use either of them, and there's lots of documentation, make sure it's following the norms, that should be done right. So using API keys and use them properly. So another thing is that you shouldn't expect the user to filter. So this links into excessive data exposure. So when someone asks for data off you, only give them back the data that they need for what they're doing. Don't give them everything and expect them to filter the data out, because there might be some data that you're giving them that they don't need, or that they shouldn't really have access to. So the information should be filtered at an endpoint level and not at the response level. So the next one is lack of resources and rate limiting. So rate limiting secures against something called DDoS attacks. So a distributed denial of service attack is when you send lots of packets of data at a website or a web service so that it makes it overflow and it brings it down in very general terms. And it either slows down services or it completely takes down the service completely. So to reduce the risk of this, you can add rate limiting to each endpoint. You can actually do this within the code. I think the one I did for my dissertation, we made it in Flask, and there is something I think called Flask limiter. You can add that to each endpoint, but you can also do rate limiting when you're hosting. So this means to make sure that you have enough resources that you're on your hosting plan, that your website isn't going to come down with too many requests, and also to limit the rate, limit the amount of requests that it can receive in a certain amount of time. You can either have a buffer. You can even have a buffer that passes them through slower to try and mitigate DDoS attacks. So I'm realizing that I'm running out of time. How am I doing? Oh,
it's okay.
Okay, that's all right. So the next one is broken function level authorization. So that links up to the secure admin functions here. So that means that certain endpoints have functions on them that only admins should be able to access, and only admins should have access to these functions. And so this comes into this point, default access should be none. So the access for these functions should be nobody to start with, and then only the people who should have access to the function should be added to that list. So security misconfig, this is quite a large one. I will come back to this one because I'll get notes up on that because it's quite a large one, and we could skip it and I could add a bit later if necessary. Next one's injection. So there are different types of injection attacks. And the main one everyone knows is SQL injection. So to ensure against injection and also mass assignment, because I think I skipped mass assignment, you should ensure that all incoming data is filtered, sanitized, and validated. So then you have improper assets management. So as systems are updated, new bits are added on here and there. You might have new microservices and new APIs. Old APIs should only be used if they are secure. Otherwise, they should be decommissioned and retired. So this is just to make sure that all information on the APIs that are still in use is all documented, so that there isn't a problem. This point is just to make sure that old systems don't allow backdoors into microservice architectures. If old APIs are still being used, they should be rewritten if they can't be secured. So the last one is insufficient login and monitoring. This is such an important one now, with the GDPR with the GDPR being enforced, and we got the new Data Protection Act too now. God, I'm so behind the time. But they kind of mirror each other anyway. So if there's any personal data being sent through the API, everything needs to be logged and monitored. And for security reasons as well, everything should be logged and monitored, because if there is an attack or data breach, you need to be able to go through the logs and find out how the data breach happened. So that's the importance of that. And I think I've covered everything. But the security misconfig now, and I think I've gone over. How am I, John? Am I okay?
We can ease into your question time. It's fine if you want to have a couple more minutes.
Okay. Yes, I will get up the. Here we are. So. Here we are. So I've actually got my dissertation in front of me right now. So the 7th point of the OWASP API top 10, you need to avoid security misconfigurations. These include unpatched systems, exposed files, misconfigured transport layer security, TLS, error messages with stacked traces, missing cross-origin resource sharing, calls policies, or security headers, and exposed server management panels. So the ways to mitigate against this would be to have a patching policy to make sure that if any security patches come out, that they are done immediately. Any unnecessary features that are implemented should be disabled. And as mentioned earlier, admin access should be restricted only to the people who need it. And I think that is everything. Ooh. Zoom out. There we are. Hope that was okay.
Yeah, that was a really good talk. We really enjoyed it. Thank you very much, Jenny, for taking the time to give us that. So now for some questions. So we like to have a fun question, just to break the ice. And this one was inspired actually by one of the other speakers, who we ended up speaking about Disney for ages the other day. So the question is, what's your favorite Disney movie?
Beauty and the Beast.
And why?
Because I'm obsessed with books and I relate to Belle.
Oh, cool. Yeah, I'm at Disney World right now because of that question. So, what got you interested in security?
This is an interesting one. So when I was finishing off my A-levels, I hadn't done too well because of mental health problems. But my mum said that I had to stay in education, and that was a must. I had actually gotten into uni. I'd gotten into the University of South Wales in Treforest to do computer security. The only difference is the word computer, but I would have been living there, and I didn't have a car at the time, and I wasn't really well enough to move out from my mum's house. So sorry, that was completely, I skipped a bit. Sorry. Going back, my mum said I had to do a degree, pretty much. I wasn't feeling well enough to do one, but she said I had to do a degree. I'd looked at computer science for a long time, but then I had an advert come up for information security, and well, it was computer security, and it looked really cool. So I looked through it. It's the first time I'd ever heard of it. This was back in 2014, and I had applied for 2 computer science degrees and 3 computer security degrees. I think one of them was part networking. But yeah, like I said, I turned out not doing any of those degrees. I pulled out of UCAS, and it turns out that a local college up near where I lived, Pontypool College, had a foundation degree on offer that was linked to University of South Wales in information security, where I could live at home, travel about half an hour to 45 minutes every morning, well there and back, and I could do the first 2 years of my degree while living at home, and then if I passed that, if I wished to do my 3rd year, I could then go to Newport Uni to get my 3rd year. So it was very much my mum telling me I had to carry on with education, because I was at a very low point and I didn't really want to. So I went for the most interesting thing I could see, and I just went for it. And then after the first, few weeks of being there, I completely opened my eyes. Like, at that point, before I started, I thought that an iPhone used Windows. I had no idea. I was thick. Well, not thick, I was ignorant. I had, and then in my first year, I was learning Kali Linux. We'd have these sessions where we all sat at Linux bots and just, we'd literally get left for 4 hours a week to try and hack each other. That was how my lecturer did it, and I loved it. So obviously I went on to do my 3rd year after that, and I came out with my information security degree. And the only difference would be that I would have lived in halls, and it would be computer security. But yeah, that's how I got into it. Sorry, that was quite a wordy reply.
No, I liked it. Also, I remember at university when we got given like Ubuntu boot disks, and we had to hack each other, and like one person just turned off all the ports and they couldn't get hacked. Emma has asked a question: where's a good place to start if you want to learn more about security? And she also said, P.S. thank you for sharing your personal experience.
Oh, no problem. God, there's so much. Like right at the very beginning, I would say to, and this isn't because I know them, but I would say to start with the Security Queens blogs. Those girls are so talented, and the stuff they're writing is both technical but also understandable for people who are new. So I would start reading their blogs. I think Immersive Labs is also very good. They've come to a few of the Women in Cyber Wales meetups that I go to. So they're awesome. Also, I'm going to be starting some YouTube videos on security. So if there are any requests on specific videos anyone wants, then I can advise on that. But a lot of people think that you need to go in through the degree route. Personally, I actually feel that that isn't the best way in, because when I graduated, I couldn't get into any of the actual security roles. I ended up in development, because I was more skilled in as a starter developer than I was to go into an info security role. And a lot of the companies have like psychometric tests, and I recently found out I'm dyslexic, so that's why I couldn't get into the roles. So the university route is very overrated. I'd say get a good portfolio together, do Hack the Box, immersive labs. It also depends what area you want to get into. And getting involved on Twitter is great, because people just want to help. So ask questions on Twitter, reach out to people, ask for help. Yeah, I hope that helped.
Yeah, so I'm going to ask one more question. Jenny, you can actually reply to the questions by typing the answers afterwards. So if there's any answers you want to give afterwards, you can. But the last question I'm going to ask is, one of the important things about API security is that it cannot be added as an afterthought. Do you agree?
I can't see. It can't be added as a
afterthought.
In terms of people would, if you've already made the API live, people wouldn't be able to access. People would already be able to access the information. So securing it after, you can't take away the information they already have. Yes, I agree. But it is possible to create a secure API and not deploy it, and then add all the security in after. But it takes a lot of refactoring and a lot more time. And a lot of companies actually wouldn't feel that was feasible. They'd want it to be either secure by design or just get it working, which I don't really agree with. But in terms of the amount of refactoring that would be needed, it would be very difficult, but it is possible. I learned that the hard way during my dissertation, because some of the endpoints weren't secured properly. So we had to sort that out afterwards. One of them actually ended up being insecure at the end, and I hadn't realized it was actually the login endpoints didn't have validation or sanitization. So I had to write up about how I would have made sure that that had about how that would have been secured in my afterthought section of the dissertation.
Cool. So thank you very much, Jenny. We really enjoyed your talk.